Hey, good morning. This is video number 2 because the first one messed up on me, so let's hope this one works out just right. We're starting a new unit, new day. So we're going to take all that we've learned from the negative and positive numbers we've been learning about, and we're going to take them into expressions and eventually equations, okay? So we're going to learn about expressions first. Now you're going to start seeing letters beside your numbers, and you're going to start seeing to the second power and all that good stuff, okay? So don't panic when you see it. Here we go. An expression. What is it? It is a mathematical phrase. Get my pen ready. It is a mathematical phrase that can contain numbers, variables, letters, and operators. Operators are like, the addition, subtraction stuff. So it can have numbers, variables, and operators. The next word you need to know, hang on, let's finish expression. An expression, this is very important. Please understand this. It does not have an equal sign. Does not. There is no equal sign if it's an expression. All right, moving down. What is a term? A term is a constant or a variable in an expression. It is separated by a plus or a minus. Examples would be 14, just a plain old number, 6n or 6x or 6a or 6d or 6z. It doesn't matter what letter they use. All letters, they just represent a number that we don't know. So all letters represent a number that we don't know, okay? And then the last thing you'll start seeing is exponents in there, okay? All right, coefficient. What is the coefficient? The coefficient is the number in front of the variable. The coefficient is the number in front of the variable. The last word you need to know about is like terms. Like terms must have both the same base, aka the variable, and the same power. So they got to have the same variable, aka letter, and they also got to have the same power. So for example, 2, 2x, and 2x squared, they are all different. None of those are like terms. Why? Because the first one is a plain old number. There is no variable with it. The second one has a variable, but the variable is x. The third one has a variable, but it's x to the square, which is not the same as just the plain old x. Okay? So all three of those are different. Now, like terms would be this. You don't have to write any of this, by the way. Like terms would be 2, 4, 2x, 4x, 2x to the squared, and 4x to the squared. What are the like terms out of that? These two. Why? Because they're both plain numbers and they do not have a variable. So therefore they have the same variable because they ain't got a variable. How about that tongue twister? The next two that are like terms are the ones with the x because they only have an x. And then the last two that are alike are the ones that have the squared with them. Okay? Now, you're going to get to a point, I'm just going to forewarn you, you're going to get to a point in your math career where you have to end up working those together, okay? But for now, they are not like terms at all. So just completely separate them for now, okay? All right, here we go. The number in front of the variable is the coefficient. That is the number. I'm gonna write it, the number. The variable is the letter. The operator is this sign. The number by itself is the constant. All right, this whole thing right here, that is the term. And this whole problem here is the expression. All right, moving on. Give an example of an expression with three terms. I've already given you one, so we'll go with it. We'll go 2y squared plus 2x plus 2. It could be there's a million bajillion ways we could do that, but that's just because they all have 2. It could also be 3y plus 2x plus 1. Okay, either one. There's a bajillion ways to do that. Another one you could have is you could have 3y plus 2x plus 1. So you don't have to have the square. You could just have another variable. Because you can't combine the y and x. All right. Number 2. List all the terms in the expression below. So we have to find all of the terms right here. There's that c. That's the only c I see, so there's 1. Okay, 8c. What's the next one? Now, this is a big deal. You got to pay attention. I've done told you this once, but we're to that point. That is not 8c minus 5 anymore. I've done told you that there was coming a day where you could not think of it that way, and today is the day. That is a negative 5. Okay? Next. That is a positive 4c squared. Let's go back to the red. How did I know that 8c was a positive? Because if there's no sign in front of it, then it is positive, just like it has been your whole life. The next one is positive 2b. Okay? All right, let's go to the next one. This one wants us to circle just the coefficient. Well, let's go back up and look at the definition of coefficient. Coefficient is the number in front of a variable. So let's circle the coefficients that are in front of a variable. That's got a variable behind it. The variable is g. This has a variable behind it, got h. Negative 4 does not have a variable behind it, so it's not a coefficient. It is a constant, okay? G has a number in front of it, so circle it. Now, let's go back just a second. I made a boo-boo, Coach Spartan made a boo-boo. Let's go ahead and circle that positive in front. That way we know it's positive. It's my fault there. Because remember, that's not a minus 2. That is a negative 2. And that's the way you have to see it. That is a negative 2g. Give an example of a like term for each of the following. So they gave us a number, or sometimes a number and a letter, and we got to make a term that is like it. Okay? So what is another term for negative 50? Any number in the world. 1 million. I don't care. You could do 5. You could do negative 5. You could do positive 50. Guys, it could do whatever. Okay? The next one, 3b. What is a term that would be like it? Any number with a b. So 2b, negative 7b, whatever. Negative half b. Okay, it could be a fraction. It doesn't have to be a whole number. It can be a decimal. All right, the next one is A. Positive 5A, just A, negative 3.2A. So it could be a lot of things. It could be a fraction. It could be basically any number you wanted in front of an A. Or it could be A by itself. And the last one, what is a like term to that? You just put any number in front of it. So it would be 2x squared, negative 100x squared. It could be even half squared. Okay? It could be whatever. Okay? (10-4). All right, moving on. Back page. Now we're going to simplify expressions. And how do we do that? We can simplify algebraic expressions by combining like terms. Cannot solve it. Okay, we cannot solve it. It's not an equation. We can simplify it. You solve equations, you simplify expressions. So we got to understand the difference in those two things. Expressions, you simplify. That's what we're doing now. You do not solve it. Don't say I solved it. You did not. You simplified it. Be careful when you're combining terms to check the sign that is in front. You got to take it with you, okay? That's no longer a subtraction sign that tells you it's negative. All right. Here we go. The Robinson family ordered snacks at the state fair. They were hungry. They like Coach Barman. They're hungry. They bought the following drinks, pizza, and ice cream cones. Notice that the letter D stands for drinks, the letter P stands for pizza, and the letter C stands for ice cream cones. Okay, they told us that. We could have picked any letter in the world, but they told us to use those. So those are the ones that we're going to use because we're direction followers. All right, D. So let's go down with all the drinks and let's put a D. D. Let's go find all the pizzas. Pizza. Somebody's hungry, man. I'm telling you, I'm getting hungry right now. Pizza. And the last one is ice cream. So we're going to use C's. All right. So now we're going to write that expression because it says to write the expression that represents all that stuff there. So we're just going to write it. We're going to go P. I'm going to draw a line right here so we can kind of not get mixed up there. All right, so we're going to go P plus P. Where did I get the plus? I'm adding them all together. We always add everything together if there's nothing there, okay? Plus D plus D. Where am I getting all this? I'm looking right up here, guys. You can't see what I'm talking about. I'm looking at all these. I'm just adding them up and rewriting them down there, okay? All those. I'm just going down the line. Now I got an ice cream cone. Now I got another pizza. Now I got another ice cream cone. I don't know why they had to do this like this. You know, they could put them in order. Jerks. We got 2 more pizzas, and then we got another drink. Lord have mercy. All right. So now let's see what the directions tell us to do. It says simplify the expression. So what we have to do now is combine all of the like terms. What like terms do we have? We have P's, we have D's, and we have C's. How many P's are there? Let's add them up. There's 1, 2, 3, 4, 5. Now, what number is understood to be in front of that variable? We talked about that. I mentioned that earlier. There's no number in front of it, Coach. You're right. But there is understood to be a number there, and the number understood to be there is 1. So if there's never a number in front of a variable, the number that is there that you don't see is a 1. Because if there's a 1 there, we don't put a 1. We just write the variable because it's only one of the variables. Okay? So there's understood to be a 1 in front of each one of those P's. So we just add them up. 1P plus 1P is 2, plus another P is 3, plus another one's 4, plus another one's 5. So there are 5 P's. Okay? I will write that in blue, my bad. There are 5 P's. How many D's are there? 3. And then how many C's are there? 2. So instead of writing it like we did on the top row, we could have wrote it as 5P plus 3D plus 2C, because they got 5 pieces of pizza plus the 3 drinks they got plus the 2 ice cream cones they got. Now let's explain in words, fancy words, how this can relate to an algebraic expression. So here we go. In an algebraic expression, I misspelled that, or I didn't. Expression. Told y'all I don't like words. Each term, I will zoom out so you can see the whole thing, can only be combined with another term. Whoops. Another like term, my bad. Another like term. This is like the example in which pizza can only be combined with pizza. Now, the reason you cannot combine them, guys, is because each variable represents something, and the other variables represent something else. Okay? So you can't combine them. Like, you can't combine drinks and pizza because the costs ain't the same. They're different. So that's why we cannot combine them. We only have to combine stuff that is like. Coach Waddell is about to join me in here. He's going to sit and listen to me while I finish. Hey, Coach, working on a video. Let me finish. I'm almost done. Color code or use a shape to identify each term and combine like terms. The first one has been done for you in questions 5 through 8. Simplify the expression. All right. So we're going to simplify the expression below. Then we're going to combine the B's, which I did in blue there. And then the regular old numbers, which I've done in red, okay? So blue and red, okay? Just like that. So we're going to do the same thing, except we're going to move over to the next problem. They just gave us an example, sweethearts. Now I'm going to come over here and do the blue. We got a J. We got another J. Notice I'm including the sign in front of it, so we're going to combine all of those. There are 3 of them. That's fine. We can have more than 2. And then the last one is just a regular old -5. Okay, -5 don't combine with anything. 4.2 plus 6.7 is 10.9 minus 5. So you would add those up, and that's 10.7, and then minus 5 gives you 5.7. Now, is it negative or positive? It was positive, and don't forget your letter. So the answer is, I can't add. That's a 9. My bad. Department boo-boo. All right, last one. C. So we're going to combine those. And then we got 2 D's. All right, combine the C's first. 20 plus 10 is 30C. And then the D's is positive 8 minus 5, so that is a positive 3D. So it's 30C plus 3D. Now I'm going to pause the video and let you and your partner work out 5 through 8. All right, welcome back in. Number 9. All right, now I'm actually going to give you the answers for 5 through 8. Forgot about that. Let's go 7A, and positive 8A is 15A. Negative 6 doesn't have a like term, so it should have been 15a minus 6. The next one, 3d, 8d, they are all like terms. That is fantastic. So we just get to combine them all, and we're going to end up with 0d, and anytime you have a 0, it is 0. Why? Because 0d means any number in front of a variable means, like 15a on this last one, it really means 15 times a, right? So right here, it really means 0 times d. What is any number times 0 in the whole world? 0. So we just write 0 because it's 0. 0 times any number in the whole world is 0. Okay? All right, we got our g. All right, 6.5 plus 1.5 is 8g. And then we have our whole numbers, which is negative 10 plus negative 3, which is negative 13. We're always adding. We're adding everything, okay? We're just adding everything. The negatives go with it, so we're adding them. We're adding everything, okay? All right, right here, the last one. Negative, there's an h, there's an h, there's an h. So we got to combine all of those. And when you combine all of those, you would have gotten a positive 4h, and then negative 1 is I'm so lonely. It was lonely. He didn't have any friends. All right, so now we're going to write and simplify an expression that represents the perimeter of the rectangle. Now we're talking about perimeters. We've been doing these on bell ringers. We know that this side up here up top is equal to the side on the bottom, right? I think y'all have told me that before. And this side is equal to this side. I think y'all have told me that. Okay, so 7.5. There we go. Okay, so we have 12y. So we have 7.5 plus 7.5 plus 12 plus 12. That's how we're going to figure it out. We just add all of these up, right? The 12 has a y, my bad. Okay, we just add them all up. That's all I've done. I just put them all together. Now, we can combine these like terms in blue, and that 7.5 plus 7.5 is 15. We could combine these like terms. 12 plus 12 is 24. So the answer to the expression is 15 plus 24y. Now, we generally write the letter before. So we generally write it like that right there. Instead of writing it 15 plus 24y, we generally write the variable first that has a number, okay? It's okay if you don't, but that's just, you got to get there because that's the way it's going to be needed to done later. All right, number 10, last one for the day. The Jacksons earned $D in a garage sale last week, and their neighbors, the Thompsons, also had a garage sale and earned 35% more than the Jacksons. Circle any of the expressions that could be used to represent the amount and the money of the Thompsons earned. Okay. They earned 35% more. Okay? So whatever they earned is D. Okay? So we want to know the amount the Thompsons earned because they earned what the Jacksons earned plus 35%. So A can't be it because it only takes the 35% times the amount they earned once, right? Well, they earned what they earned plus 35% more. Okay? So A cannot be it. B can be because it took what they made and then times it times 35%. Now, A could have been right if they did 1.35 times D, but they didn't. They only did 35%. So if D was an imaginary number of $2, right, 0.35 times 2 is not even $1. So if the Jacksons earned 2, if we did it by A here, we would have said the Thompsons only earned less than $1. That's not right, okay? Right here, they earned $2, plus they earned the more money times the $2. C, $2 plus 35%? No, because 35%, when you're talking about percent, you have to multiply. So C is not it. D, Is D it? No, D is not it because 1.35 actually means 135%. Okay? That's not it. You could have done, as I told you earlier, 1.35 because that means 135%, which is 1 times the 35% more they made times the D, which is the original. All right. That's it for today. To your homework you go. Adios, amigos.